If there is one device that causes more arguments between fire alarm technicians and HVAC technicians than anything else, it is the duct smoke detector. These devices are notorious for being hard to find, hard to test, and prone to false alarms. But they are also a critical life safety component. Today, we're going to break down exactly why duct detectors fail, the science of differential pressure that makes them work, and the correct way to test them so you don't get called back at 2 a.m. for a false alarm. First, let's define what we are looking at. A duct detector is essentially a standard smoke detector head inside a special housing mounted on the outside of an air duct. Its job is not to detect a fire in the room. The ceiling detectors do that. The duct detector's job is to sense smoke traveling through the HVAC system itself. When it trips, it performs a specific function called shutdown. It kills power to the HVAC fans and closes dampers to stop the building from pumping toxic smoke into every room. The first challenge with these devices is simply finding them. Unlike a ceiling spot detector, duct detectors are often hidden in the darkest, dirtiest parts of the building. You will find them in mechanical rooms, high up in warehouse rafters, or hidden above drop ceilings servicing rooftop units. A major failure point I see is accessibility. If a detector is installed behind a wall of conduit or wrapped in insulation where you can't open the cover, it is impossible to service. And if you can't service it, it will eventually fail. Now, let's talk about the hardware. A duct detector has two pipes sticking into the airflow: the sampling tube, or intake, and the exhaust tube. The sampling tube has holes drilled along its length. It catches the air moving through the duct and forces it into the smoke chamber. The exhaust tube then pushes that air back out. Here is the critical part. The holes on the sampling tube must face into the airflow. I have seen countless installations where the tube was installed backward, meaning no air ever enters the detector. That device is useless.
This brings us to the science: differential pressure. Duct detectors rely entirely on air velocity. If the HVAC fan is off, or if the belt is broken, the detector will not work because no air is being pushed into the sampling tube. To work correctly, there must be a pressure difference between the intake and exhaust. Manufacturers specify a range of acceptable airflow, usually between 300 and 4,000 feet per minute. If the air is moving too slow, it won't enter the tube. If it's moving too fast, it creates turbulence.
So why do they false alarm so much? The answer is simple: dirt. HVAC ducts are the lungs of the building, and they breathe in dust, pollen, and construction debris. Over time, the air filters in the unit get clogged, which changes the pressure in the duct. Furthermore, fine dust bypasses the filters and coats the inside of your smoke detector. When the sensor gets dirty, it becomes hypersensitive. A little bit of humidity or a change in fan speed can trick a dirty sensor into thinking there is a fire.
Let's look at the most common installation mistakes. Number one is placement. You cannot install a duct detector right next to a bend or an elbow in the ductwork. Air moves like water. When it hits a turn, it becomes turbulent and chaotic. A detector needs laminar or smooth airflow to sample correctly. Number two is tube length. If the duct is 4 feet wide, but the sampling tube is only 1 foot long, you are only sampling 25% of the air. The tube needs to span the width of the duct to catch smoke effectively.
Because these devices are often hidden above ceilings, the fire code usually requires a remote test switch, or RTS, to be mounted on the wall or ceiling below. This usually has a key switch and an LED. It allows you to test the device without getting a ladder. The failure I see here is labeling. I often see a row of 4 test switches on a wall, labeled RTU 1, 2, 3, and 4, but nobody knows which unit on the roof is number 3. Always label the location clearly.
Finally, how do we test them? Blowing smoke at the outside of the box does nothing. You have two options. Option 1 is the manometer test. This is the pro method. You connect a pressure gauge to the intake and exhaust ports to verify the tube is actually pulling air. Option 2 is introducing smoke directly into the sampling port or opening the cover to spray the head. But the most important part of the test isn't the alarm, it's the shutdown. When that red light comes on, you must visually verify that the HVAC fan has stopped spinning. If the alarm sounds but the fan keeps running, the system has failed.
Duct detectors are a pain, but they save lives by preventing smoke from spreading. If you take the time to check the tube orientation, measure the pressure, and keep them clean, they will work reliably. If this deep dive helped you, please hit like and subscribe. We upload new field training videos every week. Thanks for watching.